So I need to check for the completeness of a binary tree. Okay, so I'm given the root of a binary tree and I need to determine if it's a complete binary tree or not. So in a complete binary tree, every level except possibly the last is completely filled, and all nodes in the last level are as far left as possible. So assuming A, B, C, D, E and F and followed by a null. So over here we see all elements have got children left and right, and however the right child of C is null, so this is valid. If we take another example, so this is A, B, C, D, E, this is null and this is G. Over here what we can see, null occurs before G. Okay, that violates the condition, since this says except possibly the last is filled and all nodes in the last are far left as possible. So over here G is not as far left as possible. So let me tell you how we will solve this. Okay, so I've got A, B, C, D, E, a null and a G. Okay, so my first step will be to count the real nodes. Okay, I will count total real nodes. So this will be, so my total real node will be 1, 2, 3, 4, 5 and 6. So in this case my total real nodes are 6. Okay, post that what I will do, so we know if this is the node and if I have to get the left child of it, or else if I have to get the right child of it. So if we represent the binary tree in an array or a vector form, if node is at index number I, then left child will be at index 2 multiplied by I and right child will be at index 2 multiplied by I plus 1. Okay, so what we do, we say hey root, we give you 1. Okay, we give you this as 1, the index. So you go to the left subtree and go to the right subtree and find out if my left subtree is a correct binary tree and right subtree is a valid binary tree. If both are true, then it will return true. So this will go to the left, so this will be 2 multiplied by 1, so this is 2. This would be index number 3, and at each index I will check whether my index is less than, sorry, whether my index would be greater than, whether my index is greater than real nodes. Okay, so over here my index is 1. Is this greater than real node? No. So we move ahead, we call the left. So this is 2. Is it greater than 6? No. So we go left. So this is 4. Is it greater than real node? No. Now we go to the right. This is 5. Is this greater than real node? This would say no. Now over here this is at 6. Is this greater than real node? No. So this is 7. Is this greater than real node? This will say yes, this is greater than real node. So over here this will return false, since 7 is greater than 6. So this will return false, this will return true, this will return true. So over here this will return true. So if we get a null, we simply return true, we don't need to check. And when we take the AND of true and false, this will return false, and over here this will return false. So in this way we can code and determine whether the binary tree is complete or not. So my first task over here is to get the total number of nodes. So I say let total real node is equal to, I call a function called count, wherein I send this root. Okay, so I need to write this count function. So over here I say function count, this will take my node. Okay, this will take my node and this will return an integer of type 32. Okay, Now its first task will be to match the node. If the node is a null pointer, in that case it will return 0. Otherwise, if the node is valid, in that case I will say I'll create a reference of this node node.borrow, and I would call this function again. So I would say self count. I would send the node reference. I'll call to the left of this, so this will be left dot clone. Okay, and this whole thing I need to call for the right. So this is self count node reference, and this is right. Okay, and post that I need to go and call a helper function which will take my root, my iterator I, and the total real nodes, the number of total nodes without counting null. So I say my helper function. Okay, so it takes in node and iterator of type I32 followed by total real nodes which is also of type 32. Okay, so now this will return me a boolean. Okay, so my first task over here is to match this node. If this node is null, in that case it would return true. If this is not null, in that case, if my I is greater than total real node, so hence it will return false. Okay, after coming out from this if check condition, I say I create a reference. So node reference is equal to node dot borrow. Post that I call my left subtree and right subtree. So let left subtree is equal to, I call the helper function again. I send my node reference the left of it and clone it, and since this is my left child, this will be, the index will be 2 multiplied by I, and I will send the total real node. Okay, and similarly I have my right subtree, so this would be right dot clone, and my index will be 2 multiplied by I plus 1. So after getting these two, I would simply return my left subtree, the AND condition of this with the right subtree. Okay, let me submit this.